We are looking for letters that represent two organic compounds that are isomers of each other. We're looking for the letters that represent two organic compounds that are isomers of each other. Let's just calculate the number of carbons on the longest chain first before we look at other things. So here we have 1, 2, 3, 4, 5. So if we find something with 5 carbons, then we can compare the two. For B, we have 1, 2, 3, 4, 5, right? But then this is an alkyne, so they cannot be isomers of each other. And then for C, we have 1, 2, 3, 4. And then for D, we have 1, 2, 3, 4, right? And then that looks like exactly what we're looking for. So for 2.1.1, we have C and D. We have the same exact molecular formulas. And then 2.12 is saying which type of isomers, chain, functional or positional, did we identify in 2.1.1. So let's go ahead and do some analysis. So at C we have an aldehyde, right? At C we have an aldehyde. Why are we seeing an aldehyde? Because we can see this kind of functional group, right? And then for D we have a ketone. Why are we saying we have a ketone? Because we have something of this manner, right? So 2.1.2 we're gonna say functional isomers, because an aldehyde is a functional isomer of a ketone, right? And then let's move ahead and go to 2.1.3. So 2.1.3 is saying that the general formula of the homologous series to which compound B belongs. So compound B is an alkyne, right? The formula is CnH2n-2. Yeah, that's all we have to do there. And 2.1.4, name of the functional group of compound F. So compound F, we have OH here, so we already know that that's an alcohol, right? That's an alcohol. So what is the name of the functional group? Hydroxyl. For 2.1.4 we have hydroxyl. And then 2.2, we're looking for the IUPAC name. So 2.2.1, we're looking for the name of compound A, right? So first things first, we look for the longest carbon chain, right? We have, let me just erase this number so that we can start from the bottom again. We have 1, 2, 3, 4, 5. We actually have 6 because we have that carbon there, right? So 6, we know that on our name is supposed to have X, right? And then it's an alkane, a haloalkane. So there is no position for the functional group, right? It's at the first position because we're just looking for one dash. So we just have hexane here. And now we can look for the branches and the halogens, right? So look at this. If you start counting from here where I started with 1, right? On the third carbon, you will get a halogen. And then if you start counting from this side, which I wrote 6 from, right? So you're going to have 6, 5, 4. So on the third carbon, you're going to have branches. So what takes preference? Is it the branches or is it the halogen when it comes to naming, right? Please just leave a comment and let me know what your answer is for this question. We're just gonna move to 2.2.2, right? So 2.2, we're looking for the IUPAC name of compound B. So compound B, we have 1, 2, 3, 4, 5. If we have 5 carbons, we should have pent, right? And then we'll look for the functional group. So this is so that will be 1, 2. So it's pent 2, Y and E, right? Now we can look for the branches. So 3, 4, we have a branch on the fourth. We actually have 2 branches on the fourth carbon. So we're gonna have 4, 4 dash di because we have 2, right? And then methyl, and that's the name for compound B. Compound C, 2.2.3. Let's go to our table and look for compound C. So we have 1, 2, 3, 4. We have 4 carbons, right? So we know that we're supposed to have but. And then this one is pretty much straightforward. We have a double bond here of oxygen. We know that it's aldehyde. So here we're just gonna have butanol, right? We don't have to stress ourselves with the position of the oxygen, because if the oxygen is not on the first carbon, then it's no longer an aldehyde anymore. We have to resort to something else, right? So 2.3. So 2.3 is saying that compound F reacts with a carboxylic acid to form compound S in the presence of a strong acid. So compound F reacts. So compound F is an alcohol, right? So we have an alcohol reacting with the carboxylic acid to form compound S, right? So acid and alcohol, we know that the name of that reaction. So 2.3.1, we have esterification, right? So that is esterification. So we have esterification for 2.3.1, and then 2.3.2, compound S has a empirical formula of C3H6O, right? And a molecular mass of 116 grams per mole. So this here, which we have, this 116, right? It is the molecular mass, right, of the compound. And we know fully well that the molecular will always be equals to N multiplied by the empirical, right? The empirical. So if we look in for this number N, which we must multiply the empirical with to find the molecular, we must say that N. So we're saying that N is equals to the molecular divided by the empirical, right? We're talking about the molar mass here. So the molar mass of the molecular is given to us as 116. So now we just need the molar mass of the empirical. So we have 3 carbons, right? So that will be 3 multiplied by 12 plus 6 hydrogen. So that will be what? 6 multiplied by 1 plus oxygen. That will be 16, right? So if we punch that in our calculator, we shall get N is equals to 2, right? So now we can say that the molecular formula is equals to N multiplied by the empirical, right? Empirical. But we know that N is 2 and the empirical is C3H6O, right? So if we work that out, we're gonna get C6H12O2. The mistake I made initially, I determined this molecular formula that we have here, and then I just left the question as it is, right? If you look at 2.3.2, it is not saying that we shall write the molecular formula of the ester, right? But the molecular formula of the carboxylic acid. Here, this molecular formula that we determined is for the ester, right? Compound S. So now what you have to do, you have to say, okay, my ester has 6 carbons, right? And then it is made up of the carboxylic acid and compound F. Compound F has 1, 2, 3, 4. Compound F is this alcohol here. It has 4 carbons, right? So if the alcohol has 4 carbons, where is the other 2 carbons coming from? They're coming from the carboxylic acid. So our carboxylic acid has 2 carbons, right? And we know exactly what that is going to be. It's going to be ethanoic acid, right? But then we need to write the molecular formula down. That will be C2H4O2.